Hello dear students. So today we will be starting this lecture number 4, where we will be basically discussing about the concepts of memory unit of computers. Okay, so you know that like human brain, if you want to, whenever we learn something, we remember that thing, and whenever we do some function afterwards, suppose then we use our previous data or the memory that we have collected many days or many months back to solve that problem. Suppose you are solving some complex mathematical problem or any mathematical problem, and there we use addition, multiplication that we have learned in our school level. So that memory is already stored in our brain, and that we are using right now to do function, something to execute some function. The same thing happens with a computer. So whenever a computer is given some data or to execute something, the computer needs some kind of space or memory to remember them. Then only it can execute the next functions. So for that we will have to understand the concept of memory of a computer. Basically we will be here studying the unit of memory of a computer. So computer needs information in order to execute something. The digital information, and obviously we can't give the information in our language, we need to give the information in digital form only. And that digital information, that is we basically call data, okay, is actually made up of, whenever we give some data, so it will be in terms of either 0 or 1, or it can be a combination of zeros and ones, and it can be any kind of combination, and it can be a binary sequence. So whenever we give, that is basically we are giving a bit, okay, the computer. Okay, so actually each of this digits that we are feeding to that computer is represented by a bit. Okay, so bit is basically a short form of binary digit. Okay, so each bit is actually representing a single number. It can be 0 or 1. Remember, it cannot be both. It is either 0 or 1. So whenever you are feeding something to the computer, if it is 0, that means you are occupying 1 bit. If you are giving 1, you are occupying another bit. If you are giving, say, 101, so you are actually occupying 3 bit. Similarly, suppose if you are giving 100,001, so how many digits are there? 1 2 3 4 5 6. So I have given 6 binary digits, so actually I am occupying 6 bit. Okay, so the concept of bit is nothing but it's a binary digit. So whenever we give a data to the computer to execute something, it will never be a only 1 bit. It can be a consist of several bits. It's not going to be only 1 bit. It can going to be a several bits. So so I will be again doing that. Say if you are having 0, that means it is 1 bit only. If you are having 1, again it is 1 bit. If you are having 0 1, it is 2 bit. If you are having, say, 1 1, it is again 2 bit. If you are having 0 0, that is again a 2 bit. Okay, similarly, suppose you have 101, it is a 3 bit. If you have 1010, it is a 4 bit, like that. So simply, whenever we call bit, this, whenever we give an input as 0 or 1, it will occupy 1 bit. But Because but the bits are very small. Whenever you want to execute some program in the computer, you cannot just do it 1 or 2 or 3 bits. Okay, so when you want to execute some function with the computer, bits are found to be very small. Okay, so suppose you want to say, so if I want to say cat itself, you may remember for cat we had 8 plus 8 plus 8, 24 bits. Okay, suppose when I wanted to say cat, it had 8 strings, it has 8 digit string, it also had 8 digit string. So in total I had 24 binary numbers, so 24 bit. So suppose if I want to write a sentence, it may be multiplied by 10. If I want to write a para, it may be multiplied by again say 100. And if I want to make a complete chapter, it may be again multiplied by say 10 to the power 4 or 5, like that. So you just imagine. So if you want to write a paragraph, or if you want to write a full letter, so 24 bits or 32 for 50 or 60 bits are not going to be enough. So that means bit is a unit of memory of a computer, but it is the smallest unit, so we can't do with bits. So bits are usually assembled in a group of 8. Okay, that can be considered as 1 byte. Okay, so 1 byte basically consists, so if you consider 1 byte, it basically consists of enough information to store a single letter, to store a single letter. If you remember in the UTF file, so every alphabet was represented by a 8 digit binary sequence. Okay, so bits are very small, so we combine 8 bits together, that is called 1 byte. Now again the same thing, if you want to execute a program, if you want to write do a work in a bigger scale, byte is also considered to be very small. So for that we have some solution. So basically we have a few units. One is called 1 kilobyte. So basically we call 1 KB. Okay, so 1 KB is basically is equal to 1024 bytes. Now you might be asking, why 1024, why not 1000? So it is not 1000, because in computer we don't talk in terms of the base of 10, we talk in terms of the base of 2. So since we are dealing with binary, we need of base 2. So if we take 1000, it will be in the base of 10 only. Okay, so 10 to power 3. So but we can't talk in terms of 10, we need to talk in terms of 2. So we need a base of 2. So for that, so that is why we have 2 to power 10. Okay, next we have 1 megabyte. So MB, you might have heard about all this thing, 1 KB, 1 MB, 1 GB data. So that's it. So again here we have 1024 kilobytes. Okay, that is nothing but 2 to power 20 bytes. So if you want to keep on going like that, you will have 1 gigabyte. So I will rather write it in capital. It is GB, this is MB, this is KB. So 1 GB is equal to, it will be again 1024 megabytes. It will be 2 to the power 30 bytes. Okay, so you can see that everywhere we have 2 is the base. Similarly, 1 terabyte TB. You might have heard about hard disk. Whenever we buy hard disk, we have this terabyte configuration only. So that is again 1024 gigabytes. So it is 2 to the power 40 bytes. Okay, and next is 1 petabyte PB. So this is again 1024 terabytes, 2 to the power 50 bytes. So if you want me to tell it in details, this value is going to be 1,125,899,906,842,624 bytes. So again you see 1 byte is nothing but 8 bits. So this whole thing 1,125,899,906,842,624 into 8, if you multiply it by this, then you have a bit. That means if you have a file of 1 petabyte, that means this file, how many binary digits are there in that particular file? This much, this whole number multiplied by 8. So this is such a huge file. That is why whenever we have a small, suppose you have written 1 page, the size is different. If you have written 10 pages, the size is different, because it accommodates more binary, it needs more binary digits to transfer the data to the computer. Again, for, as we say that for processing the data, we cannot, computer cannot just take 0 1 1. So it needs a combination of zeros and ones. So usually when we say 1 bit, it is 0 and 1 only. Okay, similarly when we say 2 bit, it is 0 0 0 1 1 0 1 1. When we say 3 bit, we have 0 0 0 0 0 1 0 1 0 1 0 0 0 1 1 1 0 1 1 1 0 1 1 1. So this is 2 power 1 is equal to 2. This is 2 power 2 is equal to 4. Here this is 2 power 3, so it is 2 to 8. So how many options we have? 1 2 3 4 5 6 7 8. 8 options. Similarly for 2 bit, 1 2 3 4. So we have 4 options, and for 1 bit we have only 1 option. Okay, so that means it also says that, so if I want to generalize it, here it is 1 bit, here it is 2 bit, here it is 3 bit. So the number of options that are available is equal to how much? 2 to power n. So it basically says that therefore n bits can be used represent 2 to the power n different binary sequences. For example, say we have decimal here and we have binary here. Say this is 0, binary is 0, 1, binary is 1. Decimal is 2, binary is 1, 0. Again I will say that try to do the conversion. We have already discussed how to convert decimal to binary. We have already done that. So if you have a doubt, you can try to do it at home. Similarly, if you want to convert 3 decimal to binary, it will be 1, 1. Similarly, if you want to convert 4 decimal into binary, it will be 1, 0, 0. Similarly, if you want to convert 5 decimal into binary, it will be 1, 0, 1. If you want to convert 6 decimal into binary, 1, 1, 0. Similarly, 7 is 1, 1, 1. 8 is 1, 0, 0, 0. 9 is 1, 0, 0, 1. And 10 is 1, 0, 1, 0. So you can see that. So for this, it is 1 bit, 1 bit. This is 2 bit, 2 bit, 3, 3, 3, 3. This is 4 bit, 4 bit, and 4 bit. So that means if you want to explain up to 10 itself, you need 4 bits. So if you want to explain all the numbers in the world, you will need more bits. So to represent larger numbers, you need more bits. Modern computers, now you might have heard that whenever you talk about computers, you may have heard about 32-bit or 64-bit configuration. That is just to accommodate larger numbers, larger data for smooth functioning of the computer. So that is all about the concept of memory units of a computer. Thank you.